Okay, I'm going to continue from where we stopped last time. Just we discussed about group numbers and ions, especially when we discussed about the main groups of elements. What we said was main groups of elements, the valence electrons can be an easy way to predict in which groups elements located. In that regard, we say that, for example, if I have group 1 element, right? Group 1 elements have how many valence electrons in their outermost shell? 1, right?
Yeah.
So they are in group 1, right? If you have group 2A, they have 2 valence electrons. They are in group 2, right? If you have group 3A, they are in group 3 because they have 3 valence electrons, right? Now, when it comes with non-metals, okay, non-metals, which we call them anions, right? We call them anions. We start with group 6, for example. Group 6, now there's a difference because sometimes we get confused with the group number or the charge, right? Group number, maybe group 6 have 6 valence electrons. They have 6 valence electrons. But what will be the charge of group 6? What will be the charge of group 6? It should be what? A negative 2. Now, my question is to you, why it is negative 2? Raise your hand, raise your hand. Yes?
Because it needs 2 electrons to be a stable octet.
Yes, it needs to have 2 electrons to achieve what we call it octet, right? What's octet? What's octet? What does octet mean? Yes, it needs to have 8 valence electrons in the outermost shell. For us, 8 is like, it's a heavenly number, right? 8 is like the number that we know or we can predict the atoms can be stable, right? So atoms basically they lose, they gain, they share, whatever, to achieve that stage, the octet stage, okay? So if you have a group 6 element, because group 6A have 6 valence electrons in their outermost shell, they have 6 valence electrons, so they need to have 2 more additional electrons. Sometimes you get confused with the minus charge. What does the minus charge represent here? What does that mean? The minus charge indicates electrons, the charge of electrons. Okay? So it's not like subtracting, like don't take the mathematical perspective here. It's like gaining 2 electrons, but we put a minus sign because the charge of electron is negative. It's a negatively charged particle. Okay? So here is also a summary of the relationship between the ionic charge and the group number. You can see 5A, for example, they gain 3 electrons because they have 5 valence electrons. And there are some examples here, N3 minus and P3 minus. And of course, there is also a little bit change in terms of names. When we name these, for example, N3 minus, how do you name them? What's the name of that? It's called nitride. Nitride. You have to use a suffix IDE. Phosphorus is said to be phosphide. Okay? You have oxygen, it's going to be oxide. Sulfur is going to be sulfide. See, we don't see that in metallic ions. For example, if you have a sodium ion, you just say sodium ion. You're not going to say sodium ion or something like that. But in non-metals, we always use a suffix IDE after the original element. Okay? So for example, I have fluorine here, but it is now fluoride. If I have chlorine, it's going to be chloride, and it continues like that. It continues like that.
I got a question.
Yes, go ahead.
If you have like 4 electrons in the outer shell,
Yes.
do you gain or lose it?
Good question. If you have 4 electrons, they neither gain or not lose, they share electrons. Yeah, it's going to be a covalent form. Yeah, it's going to be a covalent form. Group 1A, 2A, 3A, they lose electron. Group 5A, 6A, 7A, they gain electrons. Group 4A, they share electrons.
So what's the valence in?
The balance is 4. The balance is 4. But they prefer to share electrons and they form what we call is covalent bonds. Okay, well, I just here also this is something that I want you to read. I'm sure that you have all in your PowerPoint presentation. Some of the ions and the occurrences here. You have sodium ion. What is the sodium? What are the occurrences of sodium ion? Where do we find them? What will happen if you don't have enough sodium ion in your body system? Okay. Sometimes, for those of you who are studying in a nursing field or pre-med or in the pharmacy area, it's better to also introduce with some of the terminologies here. Hyponatremia and hypernatremia. What does that mean? The word hypo is always indicating that deficiency of something. Yeah, it's a small amount, right? So the lack of sodium, the lack of potassium, these are the main ions in our body system: sodium, potassium, calcium, magnesium, and chloride ions. So I would suggest you to read these maybe in one of the tests. Maybe I may ask you. It's not too many. There are like 5 of them. And then that original names are also here. Like potassium, its Latin name is kalimia. Okay, so lack of potassium in our body is said to be hypokalemia, and if you have excess amount of potassium, it's said to be hyperkalemia. It's the same as for natremia, hyponatremia, and hypernatremia, which is excess and low, and the source and the function are also be indicated here. Okay, now let's see some of the learning checks. So let's do this together. We have, how many valence electrons does aluminum have? What do you think? What will be your answer? Raise your hand and tell me your answer and your reason. 3. Why do you think they have 3?
Because it's in group 3.
Yes, it's in group 3. If you look on a periodic table, if you look at aluminum is found in group 3. Aluminum is a main group of element, a main representative element. It's in group 3, so it should have a valence electron of 3. Does that make sense, everybody? How does aluminum acquire an octet? Yes. It must lose 3 electrons, right? It must lose 3 electrons. Let me ask you a general question. Why do you think metals lose electrons? What's the reason? Yes.
Because they have low ionization energy.
Very good. They have low ionization energy. They have low ionization energy. That's one of the main reasons that metals lose electrons. Ionization energy. It is the energy that is required to remove valence electrons, right, from the outermost shell of an atom. So what's the answer here?
1.
How does aluminum acquire an octet? Number 1, loses 3 electrons. Does that make sense, everybody? If anybody has any question, please let me know. Okay. What is the ionic charge of an aluminum ion? It should be 3 plus because it's a positively charged ion. It's a metal, so it should be 3 plus. And in that regard, what's going to be the symbol for the aluminum ion? A plus 3, right? Does that make sense, everybody? Okay.
Can you explain?
Yes,
C,
Alex.
please?
Where?
C.
Right here?
Yeah.
Yes. What is the ionic charge of an ion, aluminum ion? Now, what's happening here is that if you have aluminum, we know that aluminum is a metal, right? Aluminum is in group 3, right? Did you find that? Aluminum is in group 3. So, to achieve octet, octet means to be stable, right? Either it has to lose or it has to gain, right? We have 2 options here. Either it has to lose or it has to gain. So what is the chance for aluminum to achieve octet? Remember, it has 3 electrons in the outermost shell. And it's also metal, right? So the big chance, when it comes with interaction, when it comes with a chemical interaction, the big chance is going to be for aluminum to give away electrons, to lose electrons, right? And it's
Okay.
to lose electrons. If you have any question, ask, okay?
Okay.
Don't hesitate to ask questions. If it loses electrons, then it becomes a positively charged. A positive sign is not like addition of something. Please don't get confused with that. A positive sign means what?
More protons than
This is more
electrons.
protons.
More protons, extra protons. It means more protons. There is a deficiency. There is a shortage of electrons, and the number of protons are exceeding by 3. It's like a prediction. Okay.
Okay.
A number of electrons are a number of protons are exceeding by 3. So a plus sign is not like you are adding, but you are losing. A minus sign is like you are gaining, because a minus sign indicates a charge. A minus sign indicates a charge of electron. Does that make sense?
Okay.
Okay. So here are the solutions. How many valence electrons aluminum have? 3 electrons. How does aluminum acquire an octet? It loses 3 electrons. By losing 3 electrons, it acquires octet. What is the ionic charge of aluminum ion? It's 3 plus. The symbol for aluminum ion is Al3+. Any question? Okay. We can also predict the ionic charge from this periodic table here. As I have told you last time, we need to focus with the main groups of elements. I'm not going to ask you to remember all of the 140 different elements. I didn't say that. But main groups of elements, group 1A, group 2A, group 6A, 7A, and 8A. We need to study them for this class. It is needed that we need to know who they are. We need to know what is their chemical properties, what is their physical properties. Right, Beverly? We need to know that. We also need to know about transition metals. That means, I'm not going to ask you, find me transition metal from here, but what is the difference between transition metals versus with the other groups of elements? Why do we separate transition metals here? Just on one side, based on what is their characteristics, in other words?
They have more than one valence.
Yes, that is very important, please. Remember this. They have more than one valence. They have more than one ionic charge. This is a very important characteristic for a transition metal. Meaning to say, for example, you take lithium, sodium, potassium, rubidium, cesium. What do they have in common? What is the common things they have here? They have one charge. All of them have one charge. You will never see any element of sodium or potassium in any compound that have a different charge. A charge other than +1. Okay? A charge other than +1. So that is called a monoatomic ion. A monoatomic ion. There is a difference between monoatomic ion and polyatomic ions. Monoatomic ions and polyatomic ions. A monoatomic ion means it's an ion that has only one charge, one fixed charge, in other words. Whereas if you take any of the elements in transition metals, I don't say all of them, but 98% of them, they form more than one charges. They form more than one. That is their, I would say, their characteristics. That is their nature. Okay? They form more than one charge. So you can't predict their charges like main groups of elements. Like these groups of elements, like the A groups of elements. The A groups are called a main groups of elements. They have fixed charges. Okay? One of the bonds that is very common in chemistry, especially in inorganic chemistry, okay, it's a part of inorganic chemistry, is ionic bond. Because ionic bond is a bond that is formed by a transfer of electrons between two species. Okay, transfer of electrons. That means an ionic bond, the main players are metals and non-metals. Okay, what do metals do? They lose electrons. What do non-metals do? They gain electrons. So you can see the transformation, and such a bond is going to be a strong bond, and is said to be ionic bond. And the compound that's formed is ionic compound. Okay, good example is sodium chloride, for example. we are very much familiar with sodium chloride. It's a common salt, right? The sodium chloride is made from a sodium ion and a chloride ion, right? What does chlorine does? A chlorine gains electron, right? A sodium loses electron, and sometimes the amount of electrons lost and the amount of electron gained, they can be proportional. And then you don't need to write a subscript like this. Okay? You don't need to write a subscript like this. But there are situations here, maybe I may explain this, how we can, we have a subscript here. Sometimes it's getting confused. How do we know that we write 3 here under magnesium? How do we know we write 2 here? So I'd like to give you maybe a kind of basic idea or basic principle. How does those subscripts can come? Or how do we write them? Let's see. Okay, we're going to write a formula that's formed from magnesium and what? Magnesium and nitrite, right? Nitrite ion. How do we write this formula? Okay, magnesium and nitrite, they react together. What kind of bond would we expect here? It's going to be ionic bond. How do I know it's ionic bond? Because this is metal and this is non-metal. So my expectation is to have ionic bond, ionic compound, right? Now the question is, they are not like sodium and chlorine. Sodium and chlorine, we have sodium plus and chlorine minus, so it is equal amount, right? So the formula is going to be NaCl. It was very easy. But here, you may have like some kinds of unproportional value. You have 2 here, you have 3 here. Magnesium plus 2, what does that mean? It loses 2 electrons, right? But nitrogen needs how many electrons? Nitrogen needs 3 electrons. But magnesium, 1 ion of magnesium can offer only how many electrons? 2. Why it offers 2? Because it is in group 2. It's in group 2. Doesn't have any choice. A magnesium ion can lose 2 electrons because it's in group 2. But nitrite ion doesn't, it's not enough for nitrite ion just to have 2, right? So what do? We need to have another magnesium ion. Now, be careful here. If you have 2 magnesium ion, how many electrons you have? 4. But the nitrogen can take only 3. We don't need to have a leftover electrons, right? The transfer of electrons means that whatever electrons lost by magnesium, it has to be gained completely by nitrogen if you form a compound, see? Otherwise, if you have a leftover charge or electron, okay, it's not going to be a compound, it's going to be a radical, it's going to be an ion. See, there's a difference between a compound and an ion. Like, this is an ion, for example. SO4 2 minus, okay? This is an ion, for example, NO3 minus. It's not a compound. It's an ion, it's a radical. Ions, radicals, okay? Well, actually, we call them polyatomic ions. But a compound, the net ionic charge of a compound must be 0, okay? Sodium chloride is a compound because the +1 and the -1, they cancel out and you get 0. It's not a charged ion. Does that make sense? So, if you have 4 electrons here, this gains 3, right? So you need to have another nitride ion, right? Now, by adding this, how many electrons you have? 6. Because this guy can offer 2, right? I mean 4. So you need to have what? You need to have 1 more. Now look here. 2, 2, 2, 6 electrons. lost and 6 electrons gained. They balance it, right? They balance it. So it means that if you have a compound that is formed from magnesium ion and nitride ion, is going to be what? The ratio is going to be what? Mg3 and 2. That's the right ratio here, okay? Sometimes I may write Mg2 and 3. Sometimes I may write Mg and 3. Sometimes I may write Mg2 and 4, you know?
Professor,
Yes.
isn't there an easier way to do that? Like, couldn't you just switch the numbers?
Yeah, that's what I want to ask.
Crisscross
Yeah.
Yes.
is very easy. You can do that.
Okay.
I'm just trying to show you,
Why?
I'm just trying to show you why is the reason, okay? But, be careful, sometimes crisscross doesn't work. There are some situations crisscross doesn't work, but we have to know, I can easily tell you, you know what? Okay, just do crisscross and go for it. You know, that's fine. But you have to know also the fundamental reason why we have 2 underneath of nitrogen, why we have 3 underneath of magnesium. Okay? You know, you can take this as an option, crisscross. You can take this as an option and you can use that. That's
So,
possible, yes.
When doing ionic
Compound, yeah.
the number of the positive charge and the number of the negative charge is the same, right?
Has to be the same, yes. Whatever electrons lost by the metal, that's very important. See, whatever electrons lost by the metal has to be gained by the non-metals. What happens if they don't gain? What happens? They are not going to be a compound. What will happen? It's going to be a polyatomic ion, a radical ion. It requires to react with some other element. It's not a compound, it's not neutral. It's a very inactive, it is called excited state, or it's called an active state. It requires to combine with other elements. Okay? So we'll discuss about that later on also.
Can we have any compound which we could not be work with CRISPR?
Maybe we have some polyatomic compounds. Okay, I might discuss that when I introduce your polyatomic ions. Okay, because we first know what are these polyatomic ions. Yeah, definitely, yes. But first we have to be introduced the what are polyatomic ions and what are they. Okay, here. You know, this chapter is actually, as I've said last time, it's a little bit thick chapter. It's very wide because there are chapters that's covered from chapter 6, chapter 7, it's not only chapter 2. So the next thing is we need to know about how do we name compounds. How do we name? Naming system is called nomenclature. Okay, the idea of nomenclature means how to name compounds. So for us to make it simple or easier, we're going to divide the naming system into 2 parts. Naming of inorganic compounds and naming of organic compounds. Okay? So we start with inorganic compounds first. Before giving the name of inorganic compound, we need to introduce about a monoatomic cation and a polyatomic cations. How do we name them? So say for example, sodium is a monoatomic cation. So what's the name? The sodium ion. Notice here that we don't have any prefix or we don't have any suffix. It's just simply sodium ion, right? If you have magnesium, for example, what do you say? It's magnesium ion. Okay? In metals, be careful. In non-metals, we're going to use what? A suffix. If you have oxygen, and then if you have O-2, it's going to be what? It's going to be oxide ion.
So group 1 and group 2 just named like whatever they're.
And group 3 too.
Group 3 too.
In group 3 too, yes. You just name and then followed by the letter ion. Okay? Now, when we come to something called a polyatomic cations, okay? What are they? These are transition metals. These are transition metals. Copper. As I've said earlier, that transition metals have more than 1 ions. They have more than 1 ions. They form more than 1 ions. Most transition metals have that tendency, have that characteristic. So we call them a polyatomic ion. The same copper in some compound forms +1, the same copper is in some conformal form is +2. Now, it's not only about the charge. There is a big difference between copper 1 and copper 2 in terms of the chemical properties, in terms of the physical properties, in terms of solubility, for example, melting point. Okay, so they are different, two different animals here. So we have to name them. We have to give them a name because they are not the same. So some of most literature used Roman numerals followed by the name of the element. Copper, Roman numeral 1. It indicates copper 1. Copper, Roman numeral 2. It indicates 2. In some literatures, they use cupreous and cupric. Cupreous and cupric. The suffix OUS is used for the lower one, the lower charge. Cupric or IC, the suffix IC is used for the higher charge. For example, iron plus 2, Fe plus 2, and Fe plus 3. You may have ferrous and ferric. Okay? This book, the books that we are using, is preferred to write Roman numerals instead of using a Greek letter, Greek word, OUS or IC. Okay? So if you have a charge of +2, you say copper 2. If you have a charge of, for example, you have a charge of iron with a charge of +3, you may say iron in bracket 3, Roman numeral 3. Does that make sense? Ammonium ion. Ammonium is, well, this is a little bit different. It's not a polyatomic ion, but this is one of the common polyatomic ion that has, it's like an exception, that has a positively charged ion. So it's called ammonium ion. So cations that are formed from non-metals in IUM. It's very interesting that they are formed from non-metals, nitrogen and hydrogen, but there is more hydrogen ion here, so it has a name of ammonium ions. Ammonium ions, yes.
What does it mean by cation formed from
Cations formed from non-metals, you have seen here, you have nitrogen, you have hydrogen here. Nitrogen and hydrogen are non-metals. But this is the exception in terms of non-metals. Cations are formed by metals, right? But sometimes there's exception. Like exception for hydrogen. Hydrogen is a non-metal.
So you're saying non-metal with a positive charge?
Yeah, like hydrogen, for example. Hydrogen is a non-metal, but hydrogen is classified under group 1, in metallic group, right? Why is that? Because hydrogen has 1 electron in its outermost shell. Has 1 electron in its outermost shell, and it's group 1. But in terms of physical property, chemical property, in terms of a lot of properties, doesn't share properties with alkali metals, right? So that's one thing. This is just one of those few exceptions that we add here. These are some of the common polyatomic ions. I would suggest you to actually study some of the common polyatomic ions. Studying some of the common polyatomic ions, because there is no way that mathematically, or there's no way like in a chemistry way we can able to find out. There are common polyatomic ions. It's in your textbook, and it's also in your PowerPoint. Yes, in your PowerPoint you can look at them. These are the common polyatomic ions, like nitrate, hydroxide. In fact, I may not have all of them here. How many of you have your textbook with you today? Carbonate. I'm sorry?
What chapter is this particular topic?
This is in chapter 2.
Chapter 2?
This is in chapter 2. But remember, last time I said to you that chapter 2 is not only chapter 2.
Yeah, that's what I'm saying. The textbook, what?
Oh, this is in, you have your textbook with you?
No.
Can I borrow this textbook? Okay, if you have your textbook, what I want you to suggest is read Yeah, you can find on page 60, 60, okay? What you need to do is, page 60 and 63, by the way, 60 and 63. I don't want you to remember or to study all of them, but the book has indicated that those common polyatomic ions are highlighted. Okay, you can see that. For example, chlorate, nitrate, chromate, sulfate, carbonate, phosphate. These are the common polyatomic ions. Page 63, page 63 in your textbook.
63?
63, yes. The common polyatomic ions. Okay?
So,
Yes.
this one?
Oh, plus.
Yeah, this have like no rules, you have to just memorize it?
Yes.
Okay.
Again, let me repeat this. Those common polyatomic ions, you need to memorize them. You need to study them.
So this one is like no rules,
Yeah.
like,
There is no rules for the common poly. I have reason to say that. Okay. Most common polyatomic ions have a suffix ending with ate. That's also one of their common feature. Nitrate, carbonate, phosphate. Okay. You know, what do you see between nitrite and nitrate here?
Or oxygen.
One extra electron.
One less oxygen than the common polyatomic ion. In reality, you don't have to study nitrite. You don't have to know nitrite. If you know nitrate, the common polyatomic ion, the mother of the ion, of the nitrate ion, you can derive a nitrite ion. Okay? Phosphate, for example, phosphate is phosphate here, right? PO3 minus. Now, I may ask you a question. What's phosphite? ITE. It's going to be PO3, 3 minus. You just take one less oxygen. So, whatever is written on as a common polyatomic ion, if you study those, there are a lot of ions you can derive by your own. There are a lot of ions you can derive by your own. So that's very important, especially the ones that I indicated, page 63, is very important to study those, because that helps you, that gives you a big room to find out what are the derived ions. Yes.
We are saying that the keyboard and the keyboards,
Yes.
and which one is more how do you differentiate, like, you
Well,
were saying as the,
Well, whenever you have the OUS ion, copper actually forms a charge of 1 and 2 in most compounds. Okay, so in most compounds, copper can have a tendency to form +1. So whenever you have OUS, if you have cupreous, it always indicates a less charge. Whenever you have IC, it always indicates a higher charge. However, to avoid such confusion, we prefer to use Roman numerals.
do we have 3 charges in some?
Yeah, that's what I'm saying. So in that cases, you know, if I say cupric, you may indicate that, wow, it might be 2, or it might be 3. So you get confused, right? So that's better. The better way is to use Roman numerals. Okay? So actually the textbook is recommended you to use Roman numerals. Negative ions are said to be anions, right? And negative ions, when we name the compound, we always use the suffix what? IDE. Say, for example, if you have chlorine, we have chloride ion. Sulfur, we have sulfide ion. From bromine, we have bromine ion. Now, when we come to polyatomic ions, we have 2 names ending in either ATE or ITE. Okay? ATE is used for most common polyatomic ion, a common polyatomic ion that can be found in most compounds. Okay? And sometimes, you know, for me, I don't have any choice. I need to know who these common polyatomic ions are. We need to know them. And most of these common polyatomic ions are ended with what? ATE. So chlorate has a formula of ClO3 and -1 overall charge. Okay? Please.
So they usually have -1 charge.
That is how they are. Chlorate, yes. Chlorate have a charge of -1.
No, I mean polyatomic.
No. This is the charge that is for chlorine. You have sulfate, for example, here. So sulfate has a charge of -2.
But during the exam, are you going to write the elements
Proceed.
and households to name it?
No, that's why you need to study the polyatomic ions. You need to study, there are not too many number. There may be 8, there may be 9, but there is no, if I tell you some kinds of mathematical way, it doesn't work for all of them. I will be confusing you, okay? There is, of course, there are, how do we come up with these numbers? There is something called oxidation number that we can calculate, but it doesn't work at all. It is suggested that to study those common polyatomic ions, take your time and study the common polyatomic ions, because knowing the polyatomic ions will help you to identify all the other ions or to derive the other ions. Like, for example, sulfate has a charge of -2. Sulfate has a charge of -2. Okay? It is a common polyatomic ion, or it is with ATE. Nitrate has a charge of -1. Okay? What is this? Phosphate. It is phosphate, has a charge of -3, right? Now, if I know ATE, honestly speaking, I don't need to know ITE. ITE is used for oxyanion. By the way, we call this oxyanion. Oxyanion because in all cases, you can see oxygen takes a part. So we call them oxyanion. Okay? ITE is used for oxyanion that has the same charge, but what? One is oxygenator. One is oxygenator. So, if I ask you chloride ion, go back to chlorate. Go back to the common polyatomic ion chlorate and take away one oxygen. That is the difference between chloride ion and chloride ion. Okay? By taking away one oxygen, there is a difference in terms of the effectiveness of the ion. There is a difference in terms of the chemical nature of the ion, the physical nature of the ion. It's a lot of things. It's not just subtracting one oxygen like a simultaneous equation, but it's also there's a difference of properties. You see, if I ask you sulfide ion, go back to sulfate. If you know sulfate, you don't have a problem to study sulfide. If I ask you nitrates, nitrites, go back to nitrate. Okay? Phosphate, phosphate. Phosphate is going to be phosphite, right? So what you need to focus is going to be the common polyatomic ion. If you focus on the common polyatomic ion, the other ion comes by their own. Yes?
So you're saying like the first one, the sulfate ion and nitrate ion, you have to know them like just by memorizing it?
You have to know
And
them
then
by memory.
The other
Yes.
one is like, if you have like one less hydrogen, it's called, you just change to ITE instead of ATE.
Less oxygen.
Like oxygen.
Less oxygen, yes. If you memorize those, especially page 63 tells you which ions that you have to memorize. They are highlighted there in your textbook. They are highlighted. If you know those, then you can derive the other ions. Okay? This will be your assignment for next week. Study the common polyatomic ions. Okay? Okay, I'm done for today. Thank you very much for your attention, and I'll see you Monday. Okay? Monday, right? And have a good weekend, everybody. Thank you.